Hi, our team did a project over the TurboFan wheel, and our team name is the TurboFan team. My name is John Matringa.
I'm Jay Romero.
I'm Andy Garcia.
Our two other teammates are unable to meet this recording session, so our other teammates are Chris Van Lelos and Erica Hernandez.
A bit of background on turbofans. They have been around since the 1970s and were debuting on the famous Porsche 935 in Le Mans.
How does a turbofan work? A turbofan's blades are like air ducts. The purpose is to not just channel cool air into the brakes, but also lead away hot air from inside of the wheel, mitigating fade, which keeps the brakes cooler and more effective under high stress braking. What is a problem statement for a turbofan? There are a plethora of turbofan wheels on the market, offering different cosmetic designs and levels of performance. However, a full set of turbofan wheels can cost upwards of $1,200, making not accessible as some would like. Bringing us to our objectives. We had completed the design and decided on what material to use for the final product. Originally, we were to use aluminum, but that proved to be less accessible to the masses. With the nylon carbon fiber filament, you can print it from your home or a local source. It fits all the objectives of the design, but it's exponentially lighter than aluminum and still retains some durability. With this new material, we are able to easily build our final product. With that, we can test and use the data to refine our design. With these factors included into the design, our main objectives of cost efficiency, weight efficiency, durability, drag mitigation, and thermal reduction have been reached.
Our customer requirement had to be two turbofans, it had to have a design, and it had to fit on his 2002 Subaru Impreza.
With the making of a turbofan and extensive research, we proposed two main materials. Aluminum being the first one. Aluminum is lightweight, cost-effective, durable, and has a high melting point. Not only does it fit the objectives, but aluminum is also an easy metal to work with, and it is easily obtained and cheap. The second material that we propose is nylon carbon fiber composite. Nylon carbon fiber composite is a type of 3D printing material that also fits the objectives of our design plan. However, our team has had trouble finding a proper 3D printer that can fit our design. Thankfully, there is such a printer provided by local libraries in the area. The nylon carbon fiber composite also is more costly than aluminum, but not by a lot. Despite this, nylon carbon fiber composite is by far lighter than aluminum and provides more options in design, being able to 3D print.
So this shows the comparison of aluminum and nylon carbon fiber. We tested different results and their different properties of these two materials. So here it shows the density, heat distortion, cost, and impact strength. So for density, aluminum had 2.7 grams centimeter cubed. Heat distortion was 600 degrees Fahrenheit. The cost was about $20 for a 3 by 5 foot sheet, and impact strength of aluminum is naturally rigid, being a metal. For nylon carbon fiber, the density of it was 1 gram centimeter cubed. Its heat distortion was 296 degrees Fahrenheit. It cost about $60 a roll, and impact strength being flexible due to the combination of nylon and carbon fiber. So this slide shows the pros and cons of nylon carbon fiber, which our team decided to use for the final product. So the pros for nylon carbon fiber is that it's excellent for prototyping and producing a strong product. It's lightweight for functional parts and has an appealing color of a semi-matte black finish. Its high modulus carbon fiber reinforced polyamide structure gives the flexibility of nylon but also the strength of carbon fiber, including lightweight. The cons is that it's more costly than aluminum, causing about costing about $60 per roll when you need two rolls to finish our product, to print our product. It requires 3D printing services if you do not have access to your own 3D printer, which makes it not as accessible as other materials. So this slide is provided to give you more information on nylon carbon fiber. First of all, it was developed for engineering and industrial applications. Nylon carbon fiber is a carbon fiber reinforced nylon filament that, as stated before, is excellent for prototyping and producing functional parts. It offers chemical resistance, durability, and signature subtle flexibility of nylon, but the structural rigidity of carbon fiber, making it a better candidate than aluminum. Exceptional thermal resistance for a non-metal material, and prints easily with less warpage than regular nylon filaments. This is our final design. It has 8 fans to channel air into the brakes and 12 slits to let hot air out. It has 15-inch diameter and a 1.7-inch width that fit to the parameters of our customer's wheel. This is our budget plan. This shows onyx or nylon carbon fiber filament, which is about $60 a roll. And the 3D printing services, since our professor provided it for us, it's free, but our estimates show that it would be about $200 for you to print it if you would go to a service. The specialized nozzles for nylon carbon filament are about $23 each. The spray paint, tarp, spray paint, and clear coat, which are needed for our customers' design, but you won't need that if you don't want to change the cosmetic design.
Due to printing complications, we were unable to print our design before this presentation, but now it's under manufacturing and we'll be testing very soon. In conclusion, the TurboFan team possesses a design that fits all of our listed design objectives. Even though we have not done testing yet, we know that the nylon carbon fiber filament is the best choice. It makes our design accessible and withstand the conditions it will be exposed to.